Guys, welcome back. So I'm back here with another rule for the derivatives. So in this video I'm going to talk about the product rule, guys, and then in the next videos I'm going to talk about the quotient rule. Guys, as the word suggests, the product rule is basically when we are like working with the product of two functions, or it could be more than two functions as well. Guys, we will start with dealing with like product of two functions, and then we can also look at some like product of three functions as well. Guys, keep in mind we are still going to rely on the power rule and some of the other basic rules that we have talked about so far in the whole differentiation or derivative section. So guys, again, I'm not going to actually derive the whole product rule or the quotient rule. It's again based on the limit definition, so you should go back and actually look at your textbooks for that if you really want to know how to do that. Here, guys, my goal is more like trying to write the rule itself, and I'm going to illustrate it with some examples, and then finally we're going to use the rules to solve examples. So guys, the product rule, the first one is the product rule that I want to talk about. The product rule for the derivatives looks like this. If we have the product of two functions, and let us say I have f times g, and we want to find the derivative of this function, derivative of the product, right? So it is equal to f prime times g plus g prime times f. So I mean, as you can see here, the derivative of the product is equal to the derivative of the first function times just the second function itself, then plus derivative of the second function times the first function by itself. So guys, the common mistake that I see sometimes students make here is because we're so used to like kind of distributing stuff. So the common mistake that I see people make here is that they feel sometimes that this is just going to be, they can just kind of distribute the derivative or the prime in this case, and they say that this is equal to f prime times g prime. But guys, this is not correct. This is not correct. One has to break it down like this. Take the derivative of the first times the second and plus derivative of the second times the first. Now, in order to actually see how this works, one has to go back to that definition and proof, and I encourage you guys to actually do that proof. One of the reasons why I'm not doing here, why I'm not showing you that proof here is like, guys, I don't have enough room here, so it's going to take me more room and more space to actually do that. And for now, I'm more interested in actually taking up different examples and just solving examples and showing you the different variety of examples. Okay, so guys, keep in mind this is incorrect, and I'm quickly going to illustrate you. Again, not going into any rigorous proofs or derivations, but I will show you that this guy is actually, this is not true, and this is actually true. Okay, so I'll take a simple example, and I think we can understand it from a simple example. Guys, I am going to get rid of this, and then I can actually show you that simple example. So let me write it over on the side so that we have it in front of us, and then we can compare. So guys, the actual product rule is f times g. Derivative of the product is f prime times g plus g prime times f. That is the actual product rule, and the one that I was just talking about, which is not correct, and that's what we should not do, is this f prime times g prime. But guys, I want to illustrate this with some simple examples that this is not correct. Well, of course, it's just going to be for that particular example, but at least that will give us some idea that yes, this is not right and this is the correct one. So guys, how about if I take the derivative, let us say I take a derivative of a product of two functions, and to illustrate this, I'm just going to use very simple functions. Let us say I have x to the power 5 times x to the power 7. Okay, so guys, if I have to find the derivative of this, let us try to look at this or do it in few different ways. Guys, one of the ways would be to just simplify the piece inside the parentheses. How about we do that first? So that is something we know is correct from an algebraic point of view, right? So we're not going to disobey any of the mathematical rules or algebraic rules for that matter. So guys, if I combine them or if I multiply them, I'm going to end up with x to the power what? We just have to add the exponents 5 plus 7, which is going to be 12, right? That is one of the ways of actually evaluating the derivative of this product. You just take the product, right? Actual product, because here we can actually do that. And then we're trying to I'm just trying to use this example to illustrate something, right? Most like this, the fact that this is true and this is not true, because I don't want any one of you to make this mistake, right? Guys, then the second step is just simply using the power rule. It's very simple, x to the power n form, right? We know the derivative of x to the power n is what? Using the power rule, it's n times x to the power n minus 1. That is called the power rule. We are already supposed to know that. So it's going to be 12x to the power 11, right? That is going to be the derivative of this function. So we should not have any doubts that 12x to the power 11 is the derivative, because whatever we did here was mathematically correct. We combined these by multiplying them, and then we took the derivative using the power rule. So we already know that this is the correct answer. Now guys, let us try and use the new rule, the product rule that we have just learned. Although if you have to do something like this on a test or a homework, I would not use the product rule, because this can be easily done just by combining these and then using the power rule. Guys, I'm only doing this to illustrate something like that this is true and this is not true. Otherwise, if I have to just do this one, I would just simply use this method and be done with it. But I'm going to now use the product rule on this particular one. But usually we should use the product rule only when we have more complicated functions and we have the product of two complex functions. Let us use that one here. So again, d over dx of x to the power 5 times x to the power 7. So we can think of, or we can treat one of these as f and this one as g. Guys, it does not matter. You can treat any one as f and the other one as g. Okay, you're still going to get the same answer. So let's go ahead and use the product rule. So using the product rule, it says take the derivative of the f function. So we identify this as f. So derivative of this is what? 5 x to the power 4, right? Using the power rule. Then it says multiply by just by the g function, not the derivative, just the g function. So it's x to the power 7, right? I'm just rewriting the g function. Guys, the next piece is you got to add to what? G prime. So which is the derivative of x to the 7. X to the 7 is 7x to the power 6, right? Using the power rule. And then the f is just simply x to the power 5. That is the product rule. We just apply the product rule because it has two pieces, and we have two pieces here as well. Guys, let us simplify. This is going to be 5x to the power, of course we have to add 7 plus 11. 7 plus 4 is 11, and then same thing here, x to the power 6 plus 5, which is also 11. These are like terms. When they are like terms, we can just combine them, and we should combine them. We get 12x to the power 11. So that confirms for this particular example that, well, we already knew that this is the right answer, and now the product rule, using this product rule, the actual product rule, actually gives us the same answer. That kind of confirms that the product rule is valid. Yes, in this case, it just only confirms it for this particular example, but guys, if we actually use the limit definition or other methods, we can also generalize this, and it is going to be, we'll see that it is valid for all different functions or products of functions, okay? So, we saw it from a simpler method, then we applied the actual product rule, and then I also want to show you the last one, which is not true, right guys? That is the mistake that sometimes students make. So you will see for this particular example that that's not going to be the actual derivative of the function. So according to this, if this was valid, then the derivative would just be the product of the derivative of these both functions, right? I already have my derivative, which I know is correct. Now let me try to simplify the right hand side and see what I get, right? Okay. So f prime, the right hand side. So I'm going to just work with the right hand side. Guys, I already have the left hand side here. So the right hand side is f prime times g prime. Okay, I'll write f prime times g prime. What is my f function? X to the power 5. Let me take the derivative of this. It's going to be 5x to the power 4, right? That is the derivative of this. And now I got to multiply by the derivative of the other function, which is going to be 7x to the power 6, right? Now, if I simplify, 5 times 7 is 35, and then I have to add 4 plus is 10. So guys, you can clearly see that this is not equal to 12x to the power 11. What does that mean? That means that this is not a correct way of evaluating the derivative of a product. Okay, so guys, please, now, I mean, I showed you these with this simple example. I illustrated you here that this is not going to work. So please don't use this when you are trying to find the derivative of a product. You can use the direct method if both the functions are simple enough. If they are not this simple, then one should rely or one should use the actual product rule, which is this one. Okay, so guys, this is what I wanted to talk about with regards to the product rule. In the next video, I'm going to quickly talk about the quotient rule, and then we will start actually applying these rules in combination with the power rule to many different types of examples. Okay, so guys, I will see you in the next video with the quotient rule.